I'm going to make this video so you guys can get a better understanding of analyzing exponential growth and decay functions. Let's start out by looking at this function. Do you believe it's growth or do you believe it's decay? Growth. It's growth. Now, if somebody asks you, why is it growth? Because as you count on your x's, right? Here's 0, 1, it got bigger. 2, it got bigger. 3, it got bigger. So it's growing, right? So over here, it's really small. From left to right, it grows. Now let's compare that with this one over here. Is that one growth or decay? Decay. It's decay. Why? Because from left to right, it decays down to a certain value. In this case, the value of 0, the y value of 0. Make sense? Yeah? Okay. What do you guys think this one is right here? Is this growth or decay? Decay. Believe it or not, it's growth. What? Okay? Because it's going to the right. Because as you're going from left to right, you see how it looks like it's at the value of -1? And then what happens? It grows in a negative direction. Okay, it grows in a negative direction. So growth from left to right is either going to go to negative infinity all the way down forever or to positive infinity, right? That's growth. But decay from left to right will always approach a certain value, in this case 0. Okay, so once again, this is decay because it approaches 0, it decays down to 0. Okay. How about, like, let me just draw one right here. Let's say this is the asymptote. And let's say here's my graph. Starts way down here and then all of a sudden it goes like that. Is that growth or is that decay? It's decay. Now you're thinking, wait a minute, it's going up. That's growth. No, that's not. Yeah, is it going to positive infinity? No, like, is it going up, all the way up to positive infinity? No. It approaches a certain value, okay? So that's technically decaying to the value of 4. Does that make sense? Okay, so if it's approaching a certain value, then it's decay from left to right. But if from left to right, it's going up, all the way up, that's growth for sure. Or if it's going down forever, that's growth, but in a negative direction. I know some of you are thinking, how's it going to be growing in a negative direction? Credit card bills, right? You get in debt, you get into more debt, you get into more debt. It's growing, but in the negative direction, as opposed to a savings account where you start with some pennies and then you double it, and you keep getting more and more money, right? So that's a positive growth. Anyhow, what about this positive growth one? What else could we say? Could you guys give me the domain value? X equals all real numbers, and you have to say x equals. How about the range? The range is y equals. Y is greater than 0. Good. Why do we know that? Because asymptote is what? What's the asymptote? 0. Now you want it as an equation to give you a horizontal line, right? This is it's the x-axis, but I want it as an equation. What's that equation? Y equals 0. Okay, so we already stated a lot about this exponential growth function. It's not a decay, it's a growth. Let's also analyze the coordinates. What coordinate is this guy right here? That's -1 and positive half, right? How about this guy right here? 0, 1. How about the next one right here? 1, 2. How about the next one up here? 2, 4. And you know what? Let me see if it actually goes. Whoops. Hold on. Okay, I zoomed out a bit, and let's look at this last point up here before it goes off the graph. What's that coordinate? Way up there. 3, 8. So all I did was write down the coordinates of the graph. Now, what could you tell me about the inputs? Are they in order? Yes, -1, 0, 1, 2, 3. Yes. So because they're in order, I could actually look at the outputs and I could see the pattern. And that pattern is going to tell me how it's growing specifically. Half. Is it growing by half? In other words, if I take half of half, do I get 1?
No, it's times half.
Is it? Okay, so 1/2 times 1/2. That's not 1, that's 1/4. Right here, 1 times half, it's not 2. So how's it? It's growing. So if it's growing, you're multiplying by a number, not a fraction. What's that number? 2, right? You guys all agree, right? If I go 1/2 times 2, that'll give me the 1. And then 1 times 2, that'll give me the 2. And then 2 times 2, that'll give me the 4. And the 4 times 2, that'll give me the 8. Yay? So how is it growing? What's the growth factor? 2. So that means that the b value is 2. Now you guys think of b value, you guys remember this? Y equals a times b to the x plus k? That's the form of exponential growth or decay function. So we know that the b value is 2. So far we have y equals a times 2 to the x. Now what is plus k? The k is the asymptote, remember? What's the asymptote? 0. So do I need to put plus 0? Not really. I don't need to put plus 0. The only thing missing is the a value. The only thing missing is the a value. I need to find that a value. How could I do that? Well, I do have a bunch of coordinates here, guys. I have a coordinate 0, 1, 1, 2, 2, 4. Pick one, pick one.
2, 4.
2, 4. Okay, let's pick 2, 4. Even though I would pick 1, 0, 1. That's easier. But let's go with 2, 4. A 2, 4, that's really an x and a y value, correct? So if I were to plug it into this, I'll be able to solve for that missing value a. So if I did take 4 equals a times 2 to the x, and x is a second power, it becomes an equation that all we need to do is solve. So what's 2 to the second power? 4. So you really have 4 equals 4 times a. And to get rid of that 4, you're going to divide by 4, divide by 4. So your a value equals 1. Got it? So we know for a fact that this function of this graph is y equals 1, which is a, you don't need it, 2 to the x. And that's your actual function that describes this exponential growth curve. Are you with me?
Yes.
It was a lot. Let's try a different one. This is a growth or a decay? Growth, right? But it's shifted 2 units down. Okay, it has a k value. So let's state everything that we can about this thing. So let's start with the domain and range. Domain's all real numbers. What about the range? Y is what? Greater than -2, which means that the asymptote's also -2. And of course, we want to state it as a equation, y equals -2. So here's the asymptote, y equals -2. Our curve never actually touches it. It looks like it does, but it never actually touches it. Let's analyze some coordinates now. What is this coordinate right here? That, whoa, xy. That is 0, -1. And this next one? 1, 0. And this next one? 2, 2. And then this next one up here, that's 3 and 6. Okay? So those are the coordinates. Now, it is kind of hard to see how it's growing. Okay? Because you can't really say, oh, -1 times something gives me 0, or 0 times something gives me 2. It's weird. This is because of the k shift. Okay, let me repeat that. This is because of the k shift. It's really easy to see the parent graph pattern, but this one is not it's not up here. It's not at the y equals 0. It doesn't have the asymptote at y equals 0. It doesn't start right here and then grow this way. It's actually down here 2 units. Does that make sense? So what I need to do is take this graph and move it 2 units up. Actually, that would be right here. And make it up here. But instead of drawing it, all I'm going to do is modify the coordinates 2 units up. Now, if I say 2 units up, am I adding to the x's or to the y's? 2 units up to the y's, because y's go up, right? So I'm going to actually just put a +2, +2, +2, +2. That way I could get a new xy table of something that looks like this, right? That way we could easily see the pattern. So check this out. I'm going to make another xy table, 0, but instead of -1, it's +1. Why? Because negative 1 plus 2 is 1. Now let's plug in 1, and I would have an output of 2. 2, what's the output? 4. And then 3, and the output? 8. So this is not the XY table of the actual graph. This is the XY table if it were the original parent graph right here at the Y value of 0 on the asymptote. So this is easy to see the pattern now. How's it growing? Look, from 1 to 2, from 2 to 4, from 4 to 8. What's happening? It's growing by what? What's your growth factor? It's growing by 2. So your growth factor, B, equals 2. That's the only reason why I drew it up here, to find out the pattern, because it's easy to see the pattern right here. It's not easy to see the pattern on the original ones. Okay? So we know that it's going to look like this. How about this guy? Is it growth or decay?
Growth.
Growth, absolutely. From left to right, it's growing to infinity. Okay, but let's state domain and range. So that's all the basic info that we could get right from the bat. Now let's find some coordinates and analyze the coordinates on an XY table. What's that coordinate right there?
0.
That is 0, 1/2, right?
Yeah.
Let me make an XY table right here.
And then it's 1, 1.
0, 1/2, and then 1, 1,
2,
and then
2, 2.
2, 2,
3, 4.
and then 3, 4, quick maths. And then, I don't think we even have another, no, we don't see it. But anyways, that's good enough. Now, remember, it's easy to find the pattern if your asymptote is at 0, which in this case it is. If there was a shift, you'd want to get back to your parent graph. This is a parent graph, okay? So we know that our equation is going to look like this. Y equals a times b to the x plus k. Now we know that the k value is what? 0. So I know that the k, I'm not even going to have it. I'm not going to erase it. I'll just leave it as 0. Okay, now we need to find out how it's growing. So from 1/2 to 1, how's that growing? By 2. And from 1 to 2, how's that growing? By 2. And 2 to 4, how's that growing? By 2. So what's the growth factor? Okay, so the b value is definitely 2. Okay? The k value we said was 0 because the asymptote is right here at the x-axis, it's the y value of 0. So let's write what we have as an equation so far. Y equals, I don't know A, I'm going to leave it as A times 2 to the x power plus 0. I don't even need to write that. Now, I need to solve for A. All I need is the A value. If I had the A value, I'd be ready to write my entire equation. So I need this A value, but I need to have a value for x and for y in order to solve for A. So where could I get an x and y value? On the table. Pick an easy one.
1, 1.
1, 1 looks easy. So let's plug in a 1 for y and a 1 for x. So I really have, let me write it down here, 1 equals a times 2. That's really 1 equals 2a. So how do I get rid of the 2 in front of the a?
Minus 2, minus 2.
Divide by 2.
Oh, divide by 2?
Yeah, right. And divide by 2. So your a value is what?
1/2.
1/2. That's your a value. So your a value is 1/2. So listen up, guys. We did a lot of work here. The a value is 1/2. The b value was the growth factor of 2. And the k value is 0. So we could actually write our final exponential growth function that represents this graph exactly. That would be y equals 1/2 for a times b. What's the b value? It's 2 to the x plus k. So you don't even need to put a plus 0. But there's your answer. Y equals 1/2 times 2 to the x. That is the exact exponential growth function represented on that graph. Okay.